going to do another example on growth and decay. The last example we did was the decay of a radioactive isotope to do carbon dating. This one is doing the growth of a population, this particular population of bacteria. Okay, so for this example it tells us that we start with 500 bacteria, and then after 1 hour the number of the bacteria has increased to 800. We have two questions we want to answer. How many bacteria will there be after 5 hours? So after 1 hour there's 800, how many after 5 hours? And then number two, how long will it take for that culture of bacteria to reach 20,000? Okay, before we do either of these questions though, we have to find K, our constant. So we start with our equation, and then we figure out what goes where. So we have the amount at time t is equal to the initial amount, e to the k t power. So using the information in the problem, our culture starts with 500 bacteria. That takes 1 hour for that 500 to grow to 800. So here's our initial amount, here's our amount now at time 1 hour. So we use this information to solve for k. Before we can use a natural log, we have to go ahead and divide that 500 from both sides. So that gives us 8/5 equals e to the k times 1 hour, which we don't need to write the 1. Okay, so now we can take the natural log of both sides. So we'll do the natural log of 8/5 equals the natural log of e to the k power. So then that k can move out to the front, k times the natural log of e, and of course the natural log of e is just 1, so 1 times k is simply k. Therefore, k is the natural log of 8/5. That's the value we can use in the two problems that we need to find. Alright, so now let's do problem number 1. How many bacteria will there be in 5 hours? We're going to use this value for k that we just found, and of course we know that the starting amount is 500, so we do 500 e to the k times t, so that's to the natural log of 8/5 times t, which in this case is 5 hours. And since k was found using 1 hour, our unit for time is in hours. Okay, now we're going to just plug that into a calculator. Be very careful about making sure you put parentheses around your exponent, or you may not get the right answer. So we plug that into our calculator like this: 500 e to the parenthesis natural log parenthesis 8/5 parenthesis times 5 parenthesis power, so that's all in parentheses there. We get 5,242.88. Well, since we're not going to probably have a partial bacteria, let's go ahead and round that. So the amount would be like 5243 bacteria in 5 hours. Alright. Next, we are going to find how long it will take for our culture to reach 20,000 bacteria. So we want the final amount to be 20,000. We, of course, know the starting amount is 500. E to the natural log 8/5 times t, number of hours. This time we don't know what t is. Okay, first thing we have to do before we can take the natural log and get rid of this e is that we have to divide the 500. So divide both sides by 500. So 20,000 divided by 500, I believe, is 40, right? And then 5 goes into 20 4 times, so 240 times. So 40 equals e to the natural log 8/5 times t power. Now it seems like this should somehow cancel out too. Don't we have a property that says e to a natural log power means that that is just going to be 8/5? I think there's a property we can use here that I had forgotten about when I did this problem on my paper. I'm going to go ahead and do this though like as if this isn't a natural log but instead is just a decimal answer in there. Then maybe I'll experiment with it and see if I can get the same answer another way. Okay, so I'm going to go ahead and do the natural log of both sides. Okay, and so then this power moves to the front, this cancels out, so we end up with t times natural log 8/5 equals natural log 40. So t will therefore equal the natural log of 40 divided by the natural log of 8/5. Alright, so then we can just plug this in our calculator. Natural log of 40 divided by the natural log of 8/5. 7.85 hours is the answer. Okay, so I just want to experiment really fast with what the property was I was just talking about before. It's kind of weird for me to experiment with this on the video, but oh well, let's do it. So back to this step right here. If I take this step and I think through this property here, I believe that this would be 40 equals 8/5 t, because I think the t would come out front, and then e to the natural log of 8/5 will just be 8/5. So now the question is, will t equal 40 times 5/8? Because if I'm dividing 8/5, it turns into 5/8. So let's see, 40 times 5 divided by 8, and we get 25. That is not the same answer as that, so I must be thinking wrong somehow. I'm going to have to look into this further, because I think there might be a shortcut. But okay, so we know it works this way because I know that that's the answer.